Hello everyone, my name is John Jenkins, and in this video I'm going to be making a neural network. So I think I'm going to try some Ruby first. So new in oh, neural net. Okay, so alright. So here's the deal with the neural network. So def changer and uh, def um, director and okay def neuron 1 and I'm sorry and okay def neuron 2 and def neuron 3 end and def output layer. And so this is inspired by I recently I recently studied some more of my artificial intelligence course, and I did some of the I was in the appendix. Basically I did the appendix or the annex of the course. Not the main course, but the introductory lessons, and they were talking about how neurons worked, how synapses work, how axons, dendrites, things like that, things of that nature. So that was they taught us how neural networks work, and they gave us a basic overview of how neural networks work. How you have the input layer, the hidden layer, and the output layer. So obviously that's really simplified, but I'm gonna try to um, I'm gonna try to yeah, I'm gonna try to implement that. So let's what is the H? Okay, let's what is the weight in kilograms? Okay. All right. Okay. Puts uh, what is the width in centimeters? Okay. All right. So basically, okay. Age 1 equals gets. Okay. Weight 1 equals gets. Okay. Alright. Width 1 equals gets. The reason I'm doing that is because these might be reserved keywords, and while I'm on the subject of reserved keywords, let me go ahead and call this function right here ahead of time so that I'm not left out. So yeah. So okay. So and the purpose of the reason I don't go directly to neuron 1, neuron 2, neuron 3 is that I need something that's going to organize these neurons and call each of these neurons. I guess I could have put all this in the exchanger, but I need something that was going to call all these neurons and collect and aggregate all the data to send them off to the output layer. Okay, so all right. So okay, all right. Width 1 equals width 1 dot 2. These all need to be integers. Weight 1 equals weight 1 dot 2 I. Age 1 equals age 1 dot 2. Okay, 1, okay, width 1, weight 1, and age 1. And remember, when you are transferring these parameters into the attributes of the receiving function, you have to have it in the same order because it's in that situation it's based on order. So when you are sending it, it's based on name. So, but when you're receiving it, it's based on order. So I have to okay, 1 1 age. So so this is going to be a very basic so okay, yeah. So input 1 equals neuron 1 age 1 weight 1. Okay, input 2 equals neuron 2 I'm not going to add weights to this. I'm not going to add weights to each neuron yet. So I'm just trying to get the basics done right now. So neuron 2, weight 1, width 1. Okay. And input 3 equals age 1, weight 1, width 1. Okay. Alright. Neuron. Okay, so output layer age 1, weight 1. I'm sorry. So input 1, input 2, input 3. Okay, so this takes all the different parameters and attributes and variables. Yeah, parameters and variables. And it sends them in different orders to different neurons. This one has the first 2, this one has the last 2, and this one has all 3. And then it brings it back and it puts it into a different variable, and then all those variables get sent to the output layer. So let me go on to neuron 1 and see. Okay, age 1, weight 1. Okay. Okay. So. Okay. Output equals age 1 times 2 plus 5. At 1, yeah. Each 1 10 and then times weight 1. Okay. So return output. Okay. Alright. So second one's going to be, if you see right here, input 2 equals neuron 2, weight 1, width 1. Okay, 1, width 1. So weight okay, output equals weight 1 minus width 1 times 10. Okay. Okay, so return output. Okay, so alright. So age, weight, and width. Age 1, weight 1, width 1. And this one, to make it simple, output equals 2 times age 1 minus 4 times weight 1 and plus 2, I'm sorry, 2 times width 1. Okay, return output. Okay, so, alright, so the output layer, yeah, okay. So I'm going to normalize, or I'm going to zero. I'm gonna put this between 0 and 1 right now, so that I don't have to wait until the end. Output equals 1 divided by output. Okay, so okay, output equals 1 minus output. So basically, if you say 1 divided by output, this is an old artificial intelligence strategy that's really old. So if you say 1 divided by output, it's going to create a number that is smaller, that is closer to 0, depending on how high output is. So the higher the number output is, the closer the number is going to be to 0. It's going to be between 0 and 1. And that's another thing I have to do, is I have to change this to a floating point number, because it's not going to work as an integer. So anyway, so this creates a number that is closer to 0 the higher the number is. And this one will, so basically the higher the score is, the closer it is to 0. So what this one does is it subtracts that number from 1. So the higher this number is, the higher this number will be closer to 1. So the higher this number is, the higher this number is, the closer this number will be to 1. So that's an old artificial intelligence trick, and I can actually, since I had the foresight to make all of these variables the same, I can just copy and paste. Okay. All right. Okay. So that's not the same as waiting. That's not the same as waiting. So so I got this right here, and why don't I go ahead and copy this output layer. Okay. All right. So final equals input 1 plus input 2 plus input 3 divided by 3. So that's going to be very simple. Final weighting, and so puts your final output is final. Okay, so input equals gets. Okay, so I know there's going to be a lot of errors in this, so let me hurry up and yeah, so file, See, I know it's going to be a mountain of errors. Let's see. Shortcuts, John J. Okay, there we go. Alright, so, yeah. Alright, what is the age? 35. What is the weight in kilograms? 67. What is the width in centimeters? I guess, would that be 30 centimeters? Okay, so it worked on the first time. So, um, yeah, so it worked the very first time. So, this is a neural network. So, uh, for some reason, it's over 1, even though, I don't know. For some reason, it's over 1, but, yeah. So, yeah, why don't I, so it worked the first time, and there were no errors. Of course, the output was over 1, so there might be some sort of issue with that. But but everything worked. Everything worked. Um, it could have been that one of the values was negative. It could have been that one of the values was negative. It could have been that one of the values was negative. That could have been, I think that was the issue. I think that this value was negative, and then I normalized it and I subtracted it from 1, and I think it added to 1. I think that's what happened. So maybe I need to do some sort of absolute value or something like that. Or maybe just change this to a plus. Maybe I just need to change that to a plus. And obviously I need to get the exchanger going in here. Okay, so yeah. Okay, so that's yeah. Okay, so what is the age? 38. What is the weight? 60. What is the width? 20. Okay, so it works now. So it works now. So I forget the I guess it's called like 0-1 bounding or something like that. So I bounded the number between 0 and 1, and I think that was the issue. I bounded the number between 0 and 1. So yeah, so it came out with the correct number. So like I said, the reason why the reason why it did not work was that the reason why I had a number that was over 1 is that one of the input numbers was negative. So when I subtracted that negative number from 1, it added to it, and because of that, it created a final number that was over 1. But now I got it correctly. Now I've got it sitting correctly. So this is my first neural network. And obviously they gain in complexity as time goes on, and they gain whatever. But yeah, so that's all I wanted to show you guys is that yeah. So I thought it was going to be so hard to do AI in Ruby compared to Python. I thought I was going to have to be stuck in Python, but I was able to make a neural network in Ruby. So it worked the first time. There was the issue with the negative number, but there were no errors. It worked the first time. So thanks a lot, everyone, for your views, and yeah. So thanks a lot, everyone. Goodbye.